Okay, so for the next problem, still same kind of directions. We're trying to prove one side equal to the other side. So if you look at this, they both are tangent squared and sine squared. Okay, so we're going between subtraction, and then these are connected by multiplication, but there's not really any multiplication that you can do. So we're going to want to pick the subtraction just like we picked the addition on that last problem, just because we can rewrite these as fractions and we can add or subtract the fractions. Okay, so we're going to pick the left side this time. Tangent squared, we can rewrite that as sine squared theta over cosine squared theta. And then we're going to keep sine squared theta the same. So if I want, I can make that a fraction and put it over 1. So I'm going to subtract my fraction, so I need to make the denominators the same. Okay, so in the numerator, we're going to have sine squared theta minus sine squared theta cosine squared theta. And then in the denominator, I just have cosine squared theta. Okay, always keep taking a look at what we're trying to get. We want to turn this into tangent squared times sine squared. Doesn't look like that at all. But if you notice, I have this sine squared over cosine squared that they turn into tangent squared. And so that might help a little bit. So what we're going to do here is we're going to take out, we're going to actually factor. So sometimes you'll be factoring in the middle of the problem. We're going to factor the numerator. So factoring will just be a GCF here. So the GCF would be sine squared theta. We take that out just in the numerator, we'll have 1 minus cosine squared theta left. And then over, still over cosine squared theta. So now, what I was saying about this tangent squared, sine squared over cosine squared theta is tangent squared theta. But we still have the 1 minus cosine squared theta. So remember, anytime you have a squared trig function and a 1, more than likely you're going to use one of your Pythagorean identities. So remember, we know cosine squared plus sine squared equals 1. We have 1 minus cosine squared. So that is sine squared. Okay, so this is the same thing as tangent squared theta times sine squared theta, which is exactly what was on the right side that we were supposed to prove that it was equal to. Alright, so once again, we picked the one that had subtraction because these two had the same types of trig functions, but with subtraction we were able to add our fractions or subtract our fractions and make common denominators, and that helped us combine them together. Okay, so for the next one, so sometimes you can look at these and they're obvious on which ones to pick. So the right hand side has one trig function. So one trig function is going to be very hard to rewrite. So of course you're going to start with the left hand side. It already has our adding fractions here. So essentially we just want to add these fractions together. We want to make them have common denominators. So the first denominator is missing sine t. And guys, if you don't like the variable that they give you, like t is kind of hard to write sometimes with the plus, just change it to x, it's perfectly fine. And then for this denominator, missing 1 plus cosine t. Okay, so I'm going to have one big fraction. Sine times sine will give me sine squared t plus, and then if I multiply all this out, this will be 1 plus, because we'll have cosine t and cosine t, we'll have 2 cosine t's, and then plus cosine squared t. And then I'm not going to multiply out the denominators. So we have 1 plus cosine t and sine t in the denominator. Okay, so cleaning it up a little bit, one thing hopefully you can spot out is sine squared t plus cosine squared t is 1. So that gives us 1. We still have this extra 1. Then we have 2 cosine t. Still have the denominator here. Remember, we're trying to get it all the way to 2 cosecant t. So I'm just going to combine this 1 and 1 and make it 2. Okay. So get kind of stuck here. If you notice, we have 1 plus cosine t and we have 2 plus 2 cosine t. So I'm going to have to do the factoring again where I look at the GCF we did in the last problem. So the GCF there would just be 2. So take out a 2. That way, now that 1 plus cosine t can cancel. So you're left with 2 in the numerator over sine t. Well, we know that 1 over sine is cosecant. So we just have this extra 2, so it's just going to turn into 2 cosecant t, which is exactly what we were supposed to get on that right-hand side. Okay, and the next one. Okay, so this has a lot going on here. This one you really can start on either side. I'm just going to go through the rules that I've been using. So because if we just look at our trig functions, this one has sine and cosine, whereas this one has tangent. So I'm going to start on the right-hand side. Like I said, there are multiple ways to do these problems. So if you can, as long as you can prove that your side works, it's perfectly fine. Okay, but by the rules that I've been going by, if you look at the trig functions, tangent is more complicated than sine and cosine. So I'm going to rewrite these with sine and cosine. So tangent we know, and now be careful because there's an A and a B here. So tangent A would be sine A over cosine A. And tangent B would be sine B over cosine B. Then in the denominator, if we rewrite it, 1 minus tangent A would be sine A over cosine A. And tangent B would be sine B over cosine B. Okay, so I'm going to make common denominator. So I'm just going to work with the numerator, like this whole part here first. So this is cosine A. We really need a cosine B to go with that. This denominator is missing the cosine A. Okay, so let's fix that part before we move on to the last part. So here, this would be sine A cosine B plus sine B cosine A, or if I want to write it, cosine A sine B, just keep my letters in order, over, and then my denominator for both of these is cosine A cosine B. So this is just the numerator for this part. So then if I look at this denominator, if I make these have common denominators, this is really just a 1 here. So it's missing cosine A cosine B. Okay, so if I fix this one, this one will just be cosine A cosine B minus, this will be sine A sine B. And the denominator for both of those is cosine A cosine B. Okay, so let me recap. We got tangent. I rewrote all these tangents as sine over cosine, just with A or B, depending on which one it was. We had 2 fractions here, so I added the fractions together by making common denominators, so we got this pink part. And then here we had 2 fractions, made them the same, because remember, this was just all 1 fraction here. Because it's multiplication, so that would get that. So because we have a fraction divided by a fraction, we're going to do same, change, flip. So keep the pink one the same. Change it to multiplication, and then flip the second one. This problem just requires a lot of writing. Okay, so now cosine A cosine B was in the numerator and denominator, so those cancel out. So you're left with sine A cosine B plus cosine A sine B over cosine A cosine B minus sine A sine B. And I just realized, so there's that. So if you compare that over here to your left-hand side, sine A cosine B plus cosine A sine B over cosine A cosine B minus sine A sine B. So we have exactly what we needed to get on that left-hand side. So that gives us the answer for that.